Hello everyone. First off, I just want to say sorry. I really wasn't feeling well on Monday and Tuesday, so I missed my office hours. So just to emphasize, your second quiz is tomorrow on Thursday. So on Thursday. So make sure to get on at your class time the same way as the last quiz. Download, do, and then upload. I do want to make a note. If you are doing it on your own paper, you do not have to write the question. You only have to write your answer. I know that might have taken some time from people. Same deal, I'm going to give you 15 extra minutes to upload your quiz. If you're like 2 minutes late, don't worry about it. I can see the time and I'm not going to take off for that. But otherwise, let's just begin, and we're going to do some practice problems today that are relevant to your quiz. So we're going to go through some old exam and questions and some old homeworks that I had made. I think that they're just very useful for what we're going over. Your quiz is going to be mostly on, let's see here, it'll be mostly on Riemann Sums. And just in general, what is an integral? So integral definition. So I'm going to make this a little skinnier. So let's go through and let's answer this question. So the following image illustrates a Riemann sum using in terms. Write each item on the right in the blank next to the corresponding expression on the left. Items B, C, and A3 refer to the labeled graphical identities above, and each item will be used exactly once. So this is from last semester's exam 3. So I thought this would be a good thing to go through. And so this is just what is a Riemann sum. So let's start with delta x. And so delta x, you need to be thinking it's the width of the rectangle. And so if we're looking at this, the width of the rectangle is represented with C. And so this would be C. All right. And then we have f of x3 times delta x. And so this is a width. And then f is a height. And so width times a height is an area of a rectangle. And so here we're looking at this guy right here. If it was f of x, I don't know, x2, then maybe it could have been the area of this guy. And also look at where it's hitting the thing. So like here, you're plugging in x3, and so it's a right sum, and so it gives you the third rectangle. If it was a left sum, it would have been plugging in x2. So this would be A3. All right. And then f of x3 is, again, that's that height of A3. And so that would be B over here. So it's the height of the rectangle. And so we have B. And then the next thing, we have our sum. So we're summing up all the areas of the rectangles. We're summing them all up. So it's all of these areas together. And so it is this sum right here. So that A1 plus A2 plus ... plus AN. Okay? And then this last guy, this is the actual area under the curve from A to B, which is represented with this integral right here. So that's going to be the integral from A to B of f of x dx. I would really recommend for tomorrow, you should be able to, without this side, if I give you these things, you should be able to tell me what those are in terms of the geometry. Like, just looking at them, you should be able to go width, area of one rectangle, height of one rectangle, the sum of all the rectangles, the area under the curve, which is the definite integral. You just need to be able to identify those really, really quick. All right, these two problems are kind of similar. And so let's go in and look at these. All right, so the table below gives the rate, R of t, at which a mayoral candidate is gaining votes t days after she announced her candidacy. Assume that the rate at which the candidate is gaining votes is increasing for the first 32 days since she announced her candidacy. Also assume that at the moment she announced her candidacy, she had 520 supporters. And so remember, this is a rate. R of t is a rate, and it's going to be at which candidate is its votes per day. And this is days after announcing. The t is. So use the right endpoint approximation with 4 equal width subintervals, R4, to approximate the total number of supporters the mayoral candidate has after 32 days. So if this is the rate, this is how much it's increasing on that day. So on day 0, they're gaining about 75 new votes per day. On day 4, they're gaining about 82 more votes per day, et cetera, et cetera. So if you wanted to find the total amount, what you'll want to do is you're going to want to take a rate and multiply it by a time to get an approximation of the total number of people per time. But it's asking specifically for R4. So what I want to do is I want to find out what is our width of our, and I'm putting this in quotes, rectangles. And so I'm going to start by taking our total days is 32, dividing it by the number of times, or number of intervals we want to divide it into for the rectangles. And 32 divided by 4 is 8. And so every 8, we put a mark. And so if you think about it, these are rectangles going up, and we want to get it on the right. And so if this is 96, actually that's kind of gross. Oh, I'll go up in here. So we're going up to 96, 152, 287, and 449. So this is at 449, 287, 152, and this one's at 96 because it's a right sum. And then the width is always 8. And so if we wanted to find R4, to find the total number, then what we're going to do is we want to take that 96 times 8 plus 152 times 8 plus 287 times 8 plus 449 times 8. So that would be the total number of voters added in those 32 days, or an approximation of it. However, there's one little piece here we've left out, and it's the starting of 520. And so you would want to add that initial 520 voters in order to get the total. So this is the total change without the 520, and then the total includes that initial amount of voters. Okay, and so you'd plug that into your calculator to find it. If it was a left sum, you would just, instead of saying it's 96 high, it'd be 75 high, 96 for this guy, 152 for this guy, and 287 for this guy. So then let's look at this real quick. So is your approximation in Part A an overestimate or an underestimate of the total number of supporters the mayoral candidate has after 32 days? Explain your response. And so if we look at this, for this 8-day period, we could have picked 75, 82, or 96 as our rate, but we picked 96, and so this is going to be an overestimate. And then here, we picked 152, so this is going to be an overestimate. And then for the third period of 8 days, we picked the 287, so this is an overestimate, and etc. And so we have that this is an overestimate. Overestimate. And then if we wanted to say our y, it would be because it is, or actually, let's say R. R is increasing, and we took a right sum. Okay. If it was a left sum, so let's say that this was L4 instead of R4, then it would have been an underestimate, and it would still be that R is increasing, but it's because we took a left sum. Now let's say this was decreasing. So if our numbers down here were decreasing and it was a right sum, then we would have an underestimate because it's decreasing in a right sum. And if it was a left sum and it was decreasing, then it would be an overestimate because it's a left sum and it's decreasing. So those are kind of like your reasonings for overestimates and underestimates. And then last, write an integral that represents the exact total number of supporters the mayoral candidate has after 32 days. Do not evaluate the integral. And so here, remember to get the exact number. Then this is an integral. And we're going from day 0 to day 32. And we're looking at that rate times that time. So r of t dt. But then we need to remember to add that initial number of voters. So this is going to get the total change in voters, because remember we're taking a rate of change and we're finding a total change with the the fundamental theorem of calculus part 1. So this is the total change, but you have to add that initial amount. If we were not given an initial amount or she started with 0, this would be gone, but it's not gone. So yeah. All right, so that was how to do this problem. Let's go over and let's do something similar. Okay. So the table below shows the migration rate, M of T of Ireland, in the period from 1988 to 1998, where T is the number of years since 1980. This is the rate that people, in thousands per year, move into or out of the country. And if I remember, there might be a typo on this thing, so just wait a moment. And so we have T, which is years since 1980. So T is years since 1980. Boop. And M of T is, let's see here, rate of people. It's thousands of people per year. 1,000 people per year. So just labeling those. So 8 years after 1980, then we're decreasing at 41,000 people per year in 1988. So is the following integral positive or negative? What does this quantity represent? Pro tip, make a graph of the data of M of T. So we're just going to kind of look at this. So we're starting at 8 and we're going to 18. So we're looking at this whole piece here and we want to know, is this positive or negative, and what does this quantity represent? So if we look, it's separated per year, but I would pay attention. Sometimes there's skips. And so we're going down 41,000. We're going down 45,000. We're going down 24,000. We're going down 4,000. Going up for 1,000. Going down 5,000. Going down 4,000. Going down 2,000. Up 8,000. Up 16,000. Up 23,000. So if we look, we have, and actually I'm going to put this in here. I'm going to go to B, and I'm going to change the color to yellow. Okay, so if we look, boop, boop, we have way more negative years. Oh, that should be not there. Okay, we have not way more. We have several more negative years than positive years, and the amount on those negative years is more, let's undo that, is more than the amount on the positive years. And so I think that this integral is going to be more negative than positive. So overall, it'll be negative. If you wanted to, you could graph these and you could see like this would be the area under the curve, and you'll see that you'll have more things under the x-axis than above the x-axis, more weight there. And then this quantity represents, well, we have the rate of people per year, and we're looking at from 8 to 18 years. So this is going to be the total change because we're taking an integral of a rate of change. So this gives a total change. So it is the total change from, actually, let's do of the population, of Ireland's population, from 1988 to 1998, it's the total change of Ireland's population, 88 to 1998, in thousands of people. Okay, so that's our answer. So this is just breaking down the fundamental theorem of calculus part 1, of you're going from a rate of change to a total change, where these are your limits of integration. So did migration in the period from 1988 to 1998 result in a net influx of people into Ireland or a net outflow of people from Ireland? And here we have that the total change is negative, and so it's going to be a net outflow. So this is kind of just rewording part A. So this is a net outflow. All right, and then we're going to skip part C. This is a mid-sum. If you want to, you could go do this on your own, but let's just not mess with this right now. Now let's do some multiple choice. All right, so this first one, if G prime of t represents a child's rate of growth in pounds per year, which of the following expression represents the increase in the child's weight in pounds between years 2 and 5? So something to look at here is we're looking at an increase. So we're looking at a total change. So that is hint for that we're going from a rate of change to a total change. So we're going to want either A or C, because we want that fundamental theorem of calculus. And we're going from 2 to 5, not 5 to 2. And so A is our answer. Just straight up, that's it. And now let's look at the next guy. So the function y equals g of t represents the relationship between the rate of change in the value of investment stocks in dollars per month and the number of months t elapsed since the stocks were purchased. Which of the following sums approximates the change in the value of the stocks over the interval of time from 4 to 7 months after the stocks were purchased? And so you're going to want to multiply to get, this is a rate, and so to get a change, you want a rate times a time. So we're going to want something where we have a g of blah times a change in time. So that means that this one is immediately out and this one is immediately out. So A and E do not have that change in time aspects. And then on these guys, you have delta t for the change in time, and here you have 0.5 for the change in time. And so we want to look at these and we want to see which one is the best. Now I'm going to say that they're all pretty okay, but one is the best. And so here, you're going to have, and let's just write it out. And so for B, we're going to have g of 4 times delta t plus g of 5 times delta t plus g of 6 times delta t plus g of 7 times delta t. And then I'm actually going to jump down to D because that one's pretty similar. So D, if we look, you're plugging in 0 as your first value. So you're going to have g of 4 times delta t plus g of 5 times delta t plus g of 6 times delta t plus g of 7 times delta t. So it turns out B and D are twins. They're just written a little bit different. So if B is correct, then D is correct. Okay? And the hint is that they are not correct. And so let's look at C real quick. So C is starting at 1 and going up to 6. And we have G. So let's see, C is going to take up some space. So G of 4.5 times 0.5 plus G of 5 times 0.5 plus G of 5.5 times 0.5 plus G of 6 times 0.5 plus g of 6.5 times 0.5 plus g of 7 times 0.5. Okay, so here we go from 4.5 to 7. And so both of these look good. So here we're just dealing with a delta t, which is specific, which is 0.5, which makes sense because we're plugging in 4.5 and then 0.5 later we're plugging in 5 and et cetera, et cetera. And in fact, if we look at this, if you were to draw this, this would be a right sum. And in fact, it's a right sum of size 6. If you were to graph these g values, and then the 0.5 is the width of your rectangles. Now here, for these to make sense, delta t, actually let's go with purple, so delta t would have to be equal to 1 because your values are 1 apart that you're plugging in. But is it a left sum or is it a right sum? Well, if we were to start on the left side from 4 to 7, then we have that left side. But we also have the far right sum, right side. So this is actually neither a left sum nor a right sum. So it is not a left or right sum, so this is not a proper approximation. So neither left nor right. So turns out C is the best answer. All right, so let's go over and look at a few more of these. All right, so we're going to skip I, though that would be a really, really good one to do just in practice, especially for the 5.2 stuff. So let's look at this guy. Oil leaks out of a tank at a rate of R is equal to F of T gallons per minute, where T is measured in minutes. Which of the following expressions represent the exact amount of oil that leaked out of the tank from 15 to 45 minutes after oil started leaking? So here, the thing that you need to pay attention to is exact. It's bolded. And so if we're looking at that, F of T is a rate. And so if we were to define these in words, then I would be the change in rate of oil leak over that period. 2 is the total change because we're looking at the definite integral. So this is the total change in oil leaked. 3, if we're looking at this, then this is a Riemann sum, which means it's an approximation, and we have F times this thing times 1/2. So we're going to have F of, so it's a rate times a time of 1/2 minute. And so it's an approximation, so 3 is an approximation of what we wrote for 2. And then 4, well, if we're looking at this, we're letting n go to infinity, and this is, we have, oh man, okay. So you have 15 plus 30k over n times 30 over n. So if we look at this, then we have that 15 to 45 minutes is your total change. So that 30 over n is your width or your change in time. So 30 minutes divided by however many intervals in. And then you have 15, your starting time that you're plugging into your rate, plus that 30 over n times k. So to get specifically the kth rate, the kth intervals rate. And so this is the same thing as this, right? So we could write them the same, and so this is same as 2. It's just written in its definition of a definite integral form. And so our answer here is for exact is 2 and 4 only. 3 is an approximation, and 1 is a change in rate of an oil leak. Okay, let's look at this next one. Actually, no, let's not look at this one. It's kind of interesting. But no, we're not going to do that. That is Fundamental Theorem of Calculus Part 2, and it is not on your quiz. Oops. All right, so now let's do 2 last problems. And so we are going to look at these. So solve for R5 of the function y equals natural log of 3x on the interval 2 to 3. And then I'm also going to add on a problem to this. So also write Rn. So we're not going to solve for Rn. I just want to write it as if we are doing Rn. So if we wanted to do R5, then our delta x is going to be equal. Oh my goodness, I can't spell right now. Also right. Okay. So delta x is our total width is 3 minus 2, and we're dividing by 5 rectangles. And so if we go over here for our Rn, our delta x is still, that's a delta, that's an x. It's going to be 3 minus 2, except now we have in rectangles. So this is 1 over n, and this is 1 over 5. Very good. And then we're looking at the right side. And so I would always just recommend maybe draw yourself a little drawing, and it doesn't have to be accurate to what you're drawing, but let's go at 2 and 3, and let's split it up into some rectangles, and then we're getting the height from the right side. Doot, 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 etc. Okay. And then we're going to add up natural log. So the first one we're going to be plugging in is 2 plus a fifth, right? Because we're looking at the right side here, and so it's going to be 1 width past 2. So 1/5 is the same thing as 0.2. And so if we're plugging that in, starting at 2, our first guy is going to be at natural log of 3 times 2.2 times your width, which is 0.2. So that is going to give you the area of your first rectangle, all right? So 3, that x you're plugging in 2.2. The next rectangle, you're going to have natural log of 3 times, and now to get the next point, you're going to have times 2.4. So you add a width there, times that 0.2. So this is your height of your second rectangle times your width of your second rectangle. And then we just keep on doing this. So plus natural log of 3 times 2.6 times 0.2 plus natural log of 3 times 2.8 times 0.2 plus natural log of 3 times 0.2. And so this is how you would solve just an R5. Notice I did not put it into its summation form. I just went rectangle by rectangle. If you're doing a definite one where you know the number, then I would just do this form. Draw yourself a little picture, and then make sure you start on the left or the right. So either you need to know you need to start at 2, or you need to start at 2 plus a width. Plug that in for your x into your function times your width, and then just keep going up on your x value until you have done the number of rectangles you need to do. Now, if you need to do R sub n, then it's a little bit different. So it's going to be similar in the fact that you're plugging in 2 plus a width as your first value, but then you're going to 2 plus a second width for your second value, and etc. And so when we set this up for R sub n, then we're going to have a sum from j equals 1 to n, and then you look, your width is 1 over n, so that's your width, times your height, which is going to be natural log of 3 times something. And that something is, I'm just going to, oh, that's not what I want to do. Let's see here. Just making that a little bit, here we go. So that width is going to be 3 times, and then you're starting at 2, and you're adding j widths. So it's going to be j times that 1 over n, or j over n if you want. And so this is how you would write your Rn. It's just width times your function, leave a little space to write this in, and you have your starting value plus j times your widths. The only thing that changes for like an ln is you start at 0 and you go to n minus 1. So that way you end up on the left side of that. So you have 1 over n times natural log of 3 plus, oh, not 3, sorry. It's 2, because we're starting at 2. So 2 plus j over n. So it's the same deal. Oh, wait, it is 3. I'm a doofus. Let's do this. So let's erase all this. So we are, yes. So it's going to be 3 times 2 plus j over n. Okay, I confused myself. Which if you look at this, same deal, r over n just starts at 1 going to n, and l over n starts at 0 and goes to n minus 1. And if you look at our picture up here, then that makes sense, because at the first rectangle, you're going to add 1 width. So at j equals 1, you add a width, and so you're taking it on the right side. But if we look at our left one, we start at 0, so you add 0 widths, so you're starting on the left side, okay? So that's just real quick how we do that. So let's look at something that's kind of similar, but we're going backwards this time. So rewrite the following Riemann sum definition of the integral in the more classic integral form, then solve it. And so if we're looking at this, you might notice that we have the limit as n goes to infinity. So this is the Riemann sum definition of the integral, so we expect that. And then we're looking for a width, and if it's not on the inside, it's on the outside. And so our width here is 5 over n, right? 5 over n, which means your interval is 5 wide. And so when we set up this guy, these two numbers, your limits of integration, should be 5 apart. Now, we want to look for something that looks like blah plus width times j. And so if we look at this, we see it twice. We have 13 plus 5j over n and 13 plus 5j over n. This lets us know that we start at 13. We start at 13. And so our limit of integration starts at 13. It's 5 wide, which means we end at 18. We end at 18. And also, this lets us know that that 13 plus 5j over n is our x value. So if we replace those with x's, our function is x to the 4th minus 1 over x dx. All right? So we just wrote it as an integral. So if we wanted to solve it, we could use the fundamental theorem of calculus part 1. And so you'd end up with x to the 5th over 5 minus, and then 1 over x is natural log of x. And you are plugging in 13 and 18 and taking the difference. So this is going to be 18 to the 5th over 5 minus natural log of 18 minus, and then you have 13 to the 5th over 5 minus natural log of 13. I'm not going to type that in, but this is what you would plug in order to solve. All right. I do want to make a note that maybe instead of doing in, we could do an approximation, and we might ask, what integral is this an approximation of? So for an example, I'm going to just kind of slide this up. Ignore this piece right here. So I'm going to erase that. Okay, and so let's say that you were given something like this. So j equals 0 to 9 of 13 plus 5 over 10j to the 4th minus 1 over 13 plus 5 over 10j. Okay, so if we're looking at this, this is the same thing as the inside here, except for your n is replaced with 10. So your width, oh, sorry, this should be 5 over 10. I forgot this part. 5 over 10. And so if we're looking at this, since we start at 0, undo. since we start at 0 and we go up to 9, then we know this is a left sum, which means this is n minus 1. So we know that there are 10 rectangles. So 10 rectangles. And so your width here per rectangle is blah over 10. So we could have written 1/2, but you need to remember that your width is actually 10 of these. And so you would rewrite it as 5 over 10 in order to get that. But this would be an approximation of this integral. So this is the exact, and this is the approximation. Yeah, that's it. And so let's zoom on it. All right, so last I would just want to do some announcements. All right, so quiz tomorrow. The rules are different. So quiz tomorrow. You are allowed all notes, the textbook, if you have it. Again, a calculus textbook would be fine. Just because I didn't say that you had to get the textbook this year. And your calculator and scrap paper. Forbidden is internet, including my videos. You can't just play my videos while you take the quiz. And then other people. You cannot work with others. You can't ask your brother or someone else in the class. Forbidden is other people. But otherwise, the quiz is the same thing tomorrow as it was last time. You just are allowed more things. So the last thing I want to say is Zoom. I am actually going to hold extra Zooms before your quiz. So there's the normal one at 3:30 today. So 3:30 to 4. I'm also going to hold a later one. And let's say that it's going to be from 8 to 8:30 tonight. So this is today. And then tomorrow, I will hold a Zoom from 11 to 11:30. Okay, so these are today's Zooms that are available and tomorrow's Zooms that are available. If you just have questions and you're working through things, I really recommend go through WebAssign, take notes on this quiz or on today's review. You are allowed to use them on the quiz tomorrow. But otherwise, good luck. And I will post the next lecture on Friday.